Hi, so for today we're going to do part 2 of our differential equation or unit 7 review packet. So we're actually going to start on number 7. So if you didn't watch part 1, go back and watch part 1 and you can do the first 6 questions. And also make sure you do the questions first and then use this video to check your answers. So let's start right out with number 7. We have a differential equation and we have an initial condition and we're going to see which of these is the solution. So first thing I'm going to do is separate the variables. I'm going to move the dx over first and then divide the y over. Next thing I'm going to do is take the integral of both sides. The integral of 1 over y is the ln of y. And then negative 2x would be negative x to the second plus c. And before I plug in that initial condition, I'm going to solve for y. So I'm going to take e to both sides, and that gives me y. Now, e can never be negative, so I can drop the absolute value. And we also learned in class last week that we can move this c to the front. So ce to the negative x squared. So I've solved for y. Now I'm going to plug in my initial condition. So they tell us that we have a 0.14. So I'm going to plug 4 in for y and 1 in for x. So that negative means that the answer is going to be negative. So this is e to the negative first. And anytime I have a negative exponent, I'm going to fix it. So that's 4 equals c over e. So if I solve for c, c would be 4e. So now I'm going to rewrite my problem. Y equals c is 4e times e to the negative x squared. Now, if I look at the answers, I know it can't be A or B. It's got to be one of these from down here. So what I remember from exponents is that when we're multiplying matching bases, we add the exponents. So this e has a 1. So this becomes 4e to the, I'm going to add these up, 1 minus x squared. So that matches D. Okay, next question, we're going to go to number 8. Okay, number 8, same type of question. So we have a differential equation and we have an initial condition. So I'm going to cross multiply. dy equals 5y squared dx. And I'm going to move the y over. So 1 over y squared dy equals 5 dx. Now the 5 can go on either side. I usually just leave it on the x side so I don't have to move it. So next step, I'm going to take the integral. And I'm going to rewrite this y squared as y to the negative second. So I'm going to add and divide, so that integral is going to give me negative y to the negative first. And over here I got 5x plus c. So now I'm going to rewrite this as negative 1 over y equals 5x plus c. I'm going to move this negative to the other side, so I'm just solving for y right now. So 1 over y equals negative 5x, and the c just stays c. And then I'm going to get y by itself, so I'm going to flip this, which means I'm going to flip the other side. Now I'm going to plug in my initial condition. So 3 is y, and 0 is x. So 3 would equal 1 over c, because that would be 0. And that would mean if I cross multiply, 3c equals 1, so c equals 1/3. So now I'm ready to write my answer. Y equals 1 over negative 5x plus 1/3. Now that does not match anything that I have so far, but I know it can't be a, b, or c. So it looks like what they did is they got rid of the fraction and the fraction. So if I multiply everything by 3 over here, that gives me 3 over negative 15x plus 1. Now it matches D. Okay, moving on to question 9. So question 9, we have dy dx equals 2y squared. So I'm going to write that down. And they give us one set of initial condition, and then we're going to solve. So basically, I'm going to solve this differential equation. I'm going to cross multiply. Divide that y squared over. Now I'm going to take the integral. So this is just like the last problem. I'm going to rewrite this, y to the negative second. And now I'm going to take the integral. So I'm going to add and divide. That's negative y to the negative first, and then 2x plus c. So I'm going to rewrite this. Move that negative over, so that's 1 over y equals negative 2x plus c. And then solve for y, so 1 over negative 2x plus c. So I'm going to plug in my first initial condition here. When y is negative 1, x is 1. So negative 1 equals 1 over negative 2 plus c. I'm going to cross multiply, so if I multiply these two here, I get 2 minus c equals 1. So I'm going to subtract the 2. C equals 1. So now I'm going to rewrite my problem. Y equals 1 over negative 2x plus 1. So now I'm going to keep solving. They tell us when x equals 2, y equals what? So now I'm going to plug in 2 for x. That gives me 1 over negative 4 plus 1, so negative 3. Final answer is B. Okay, number 10. What is the particular solution to the differential equation dy dx equals xy squared when the initial condition y of 2 equals 1? Okay, so I'm going to move this to the next page so I can see the answers at the same time. So I'm going to go to the next page and rewrite the problem. Dy dx equals xy squared. And then I'm going to write the particular solution. Y of 2 equals 1. Okay, so I'm going to cross multiply. Dy equals xy squared dx. Divide that y squared over. Next step, I'm going to take the integral. So that would be y to the negative second dy equals x dx. I'm going to add and divide, so negative y to the negative first. And this would become 1/2 x squared plus c. Again, very similar to the other ones. So I'm going to rewrite this and move that negative over. So 1 over y equals negative 1/2 x squared plus c. And I'm going to move the y to the top, so 1 over negative 1/2 x squared plus c. So now I've got a point we're going to plug in. We're going to plug 1 in for y and 2 in for x. This gives me 4 divided by negative 2, so negative 2 plus c. I'm going to cross multiply, so negative 2 plus c equals 1. C would be 3. So rewriting my problem, y equals 1 over negative 1/2 x squared plus 3. Okay, this doesn't match any of the answers. I know it can't be any of the ones with e in it though. And I do have a fraction and a fraction, so if I multiply everything by 2, that'll get rid of that fraction and hopefully match an answer. So if I multiply everything by 2, I get 2 over negative x squared plus 6. And yep, that matches D. Okay, moving on to number 11. So this one has the calculator symbol. A puppy weighs 2 pounds at birth and 3.5 pounds 2 months later. So I'm going to write that down. So I've got the weight of the puppy. The puppy weighs 2 pounds at birth. And he weighs 3.5 pounds 2 months later. So W equals 2 when T equals 0. W equals 3.5 when T equals 2. If the weight of the puppy during its first 6 months is increasing at a rate proportional to its weight, then how much will the puppy weigh when it is 3 months old? So I want to know how much the puppy will weigh when it's 3 months old. So they tell us, we've talked about this in class, that we see it increasing at a rate proportional. So that we're going to write a proportion statement. The weight of the puppy is increasing at a rate, so dW dt is proportional, so K, to its weight. So here's our differential equation that we're going to solve. I'm going to separate my variables, dW equals KW dt, and I'm going to move the W over. So 1 over W dW equals K dt. I'm going to take the integral. That's the ln of W equals KT plus C. I'm going to do e to both sides. W equals, now I can move the C to the front, CE to the KT. Now that general solution, I told you guys you could just memorize that. Whenever you have a proportional rate, the answer is always going to be CE to the KT. So you don't have to go through this, but if you want to, if you forget it, you can always come up with the answer on your own. Okay, so let's plug in some initial conditions. I'm going to start with the 0. So 2 equals CE to the K times 0. E to the 0 is 1, so C would equal 2. So my new equation, W equals 2E to the KT. Next, I'm going to plug in my next initial condition. 3.5 equals 2E to the K times 2. So this one I've got to solve. I'm going to get my calculator out. Okay, so first I'm going to divide by 2. I know that's 1.75. Then I'm going to do ln to both sides. So on my calculator, I'm going to do the ln of 1.75. So I get a decimal, and I'm going to hold on to that for a minute here. I'm just going to set it down. Okay, so, but that's equal to 2K. So now I'm going to divide that by 2, which gives me 0.2798. So that's what K is. So I'm going to write my solution again. Now that I know K and I know C, W equals 2E to the K, 0.2798 T. Now I can see how much the puppy weighs when he's 3 months old. 2E to the decimal value. So let's plug that in our calculator. 2E. Now I'm going to pull this decimal up so I don't have to enter it in again. Times 3 gives me 4.6 approximately. So let's see if that's an answer. Yep, it's choice B. Okay, last question, number 12. During optimal conditions, the rate of change of the population of a certain organism is proportional to the population at time t in hours. At time t equals 0 hours, the population is 300. At time t equals 24 hours, the population is 1,000. At what time t is the population 500? So I'm going to go to the next page so I have room to write. And I'm going to write all of that down here. Just bump it up to the top. There we go. Okay, so I'm going to make a list here. So first off, they say the rate of change of the population of a certain organism is proportional to the population. So dp/dt, the rate of change of the population, is proportional to the population. Now I know already if I solve this, I'm going to get P equals CE to the KT. So I'm just going to skip to that step. Again, you can totally separate the variables and solve. You'll get the same thing. So I'm going to make a list of my givens. At time t equals 0 hours, the population is 300. At time t equals 24 hours, the population is 1,000. We're going to find the time when the population is 500. Okay, so I'm going to start plugging in. I'm going to start with the 0, 300 for P, and 0 for T. So again, e to the 0 is 1, C times 1 is 1, C is 300. So now I know C, P equals 300, e to the KT. I'm going to now use my second set of givens, plug in 1,000 for P, and 24 for T. So I'm going to get my calculator out for this one. I'm going to divide 1,000 by 300, which is 33.3 repeating. 3.3 repeating. So I'll leave it at 10/3, I guess, equals e to the 24k. Then I'm going to do ln to both sides. So I'm going to type that in my calculator. So I get a decimal. I'm going to divide that by 24, so that'll give me k. K would be 0.050. So now I've got my, I've got my C and my K, so P is equal to 300 e to the 0.050 t. So now I'm going to find the time when the population is 500. So I'm going to plug those in next. 500 for P. So I'm going to divide 500 by 300, 5/3. And then I'm going to undo the e by taking the ln of both sides. So now I need the ln of 5/3. That gives me 0.5108. And I'm going to divide that by the decimal we got earlier. So I'm going to pull that up, the 0.00. Or the 0.050. I'm going to pull that up. Divide, I get 10.182. So there's my final answer. But if you look at the answers, they're not in decimal form. So what I would do is go back and check all these, see what the decimals are, and compare them. So I went ahead and did that for you. Letter A, we get 12.828. Letter B, 6.857. Letter C, 3.125. And letter D, 10.18. So D is the correct choice. If you also look at D, it matches a lot of the things we did. We have the ln of the 5/3, which we did. We divided by the k, which looks similar to the one on the bottom here. So if I had to guess, D would be the correct guess also. Okay, that concludes part 2 of the review sheet.